Hi everyone. Today we're going to be taking a look at how to complete the square, and we're going to be using that to solve a quadratic equation. So let's remind ourselves, what does that mean when I say solve a quadratic equation? It means I want to get x equals something, right? I want to get some answers for when I plug in x here. This is going to make sense. Whatever this goes down to, it's going to go down equals 0. So we need to start by taking a look at why we're going to be using completing the square, right? Something like this, normally we'd be able to do it using the two parentheses deal, and we're going to find factors of 16 to give us a 6. Now, we all know how to do that at this point, but generally we'd use completing the square when we couldn't do that. So when you can't do that, then we have to look at another method. And this would be another method to give you these x's. It's a more powerful method. Now to begin, I think we should go over the why. And in the why, we should be taking a look at what exactly is the reason we came up with this method. How did we come up with this method? Well, it has to do with simple factoring. So what's the easiest thing to factor? Well, it would be something like this one, isn't it? Like if we did something like x plus 3 squared. If you take a look at something like this, equals 0, this is super simple to solve, isn't it? It's going to be quite obvious after we square root the squared, and we square root to 0, we're going to get x equals minus 3, right? And a simple result like this one is very nice. So what we're going to try and do is brute force something like this into something like this. If we could take this and turn it into this, well then we can get our x's, can't we? So we need to figure out how to do that. So first, let's get rid of this. And let's talk about what's the easiest method of factoring. Well, remember our x plus 3 example was nothing more than this, right? It was nothing more than x plus 3 times x plus 3. What happens if you factor this out, right? If you do the first term, the last term times each other, and then the inner and the outer, right? Well, you're going to get what? X squared plus 6x plus 9. Well, take a look. This kind of looks a lot like what we got over here, doesn't it? Yeah, it's kind of like that, but a little bit different numbers, right? We got a little different numbers going on here. So what we have to do is take a look at this relationship. How do you go from this 6x to 9 into this x plus 3 world? Well, what mathematicians did is they realized, oh yeah, here's how it's done. We got this one. Well, this term is just half of this term, whatever this is. It's always half. And then this one is just that half, but squared. So what do we got to do? We got to basically take half of this and square it to figure out what this number is, and just add it. And then we can create something like this to get something like this. So let's see if we can do that up here. Let's see if we can do that technique where we take this, half it, and then add it so we can factor it. I'm going to rewrite this over here. Minus 16 equals 0. And why don't we try that? For now, we're just going to be looking at this stuff, right? This minus 16 doesn't help us at all. We're just going to ignore it. So take this minus plus 6. What is that divided by 2? So we're going to take 6 divided by 2. Gives us 3. And then we're going to square it, giving us 9. So 9 is the magic number we're going to be adding here. So right here we get x plus 6 plus 9. I still have this stuff over here, so I'm not going to forget that. Minus 16 equals 0. And now look, looks pretty good, right? We just took our original problem, and now we can factor this, can't we? This turns into our x plus 3 squared. And then we get a minus 16 and 0. But wait. You must be thinking to yourself, whoa, you can't just go around adding 9 wherever you want to make the problem good like this. Well, what are we going to do in order to take care of this 9? In the rules of math you should have learned from way back in pre-algebra, whatever you do to one side of the equation, we're going to do the exact same thing to the other side. So it's as easy as adding a 9 here. Now we got these two 9s added on both sides. So we've got all the rules of algebra followed. So I'm just going to simplify this. So what would this be here? We have the minus 16 still. And now we have a 9 here instead of a 0. And this, guess what? This is something nice. We can solve this for x now. What do we do? Get rid of the 16. We're going to add 16. You get x plus 3 squared equals 16 plus 9 is 25. Right? How do we solve this here? We want to do the opposite of squaring, which is square rooting, right? And again, both sides get it. So what do you get here? X plus 3 equals 5. And what are we forgetting here? Anytime you square root something, remember, you need the plus and minus. That's what's going to give us the two answers, the two question marks. And then lastly, we'll subtract the 3, and we'll get what? In the plus 5 case, we'll get 5 minus 3, we'll get 2. In the minus 5 case, we'll get minus 5 minus 3 gives us minus 8. And these are our final two answers. So what are the big takeaways here? The big takeaway is you take your quadratic. You take your b term, your second term with the x. You cut it in half, square it, and add that to both sides, just like we did with the 9. And then finally, you made something here, you factor that, and just take care of all the rest of the algebra all the way until you get your final answer. And that is completing the square.